Okay, so let's look a little bit more at this gray matter and the white matter. The gray matter, like I said, definitely butterfly shaped. We've got those posterior horns, and they are referred to because a lot of times when you're looking at all of the terminology, okay, does everybody remember the term dorsal? And of course, dorsal meaning towards the back, so therefore the posterior. The other part that we're going to see being present, we're going to have a posterior or dorsal root. Now, let's go back and let's look at this again, because the picture's kind of not participating. Oops, wrong computer. Do you see that right there? Okay, that's the root that's being referred to. That dorsal root, that great big huge bump that looks like it's present, okay, let's just kind of think about what it's telling us here. Now remember, we said that we're going to have sensory information go in, and I need to have motor information come out. Okay? So look at what it's telling us. That dorsal root carries only sensory fiber. That's letting me know right there information that is now entering on that posterior side of the spinal cord. Is everybody with me? So, if I look at my segment, anterior, posterior, okay, is everybody with me? So coming in is that spinal nerve, and then when it branches, and the branch that goes to my posterior side, carrying sensory information, my senses. And in this case, if we're thinking about the spinal cord, like C, the cervical, thoracic, lumbar, and so forth, think of it being information from out here, okay, this periphery in. What I'm going to find is I'm going to have some ventral horns. I will also have a ventral root. But this time, look what it's carrying. Motor. So like I said, I got the one coming in, going to branch, go to the posterior side, come to the anterior side, sensory information, motor out. Are you following me? Because now I have created, basically created a circuit. Have I not? So on each side of that spinal cord, there's left, right, okay? The butterfly, left, right, okay? And I'm going to have information from both sides be able to come in, get to the spinal cord, and motor information come out. I've created almost like what looks like a circuit. I need you guys to yeah. Okay. So when I look at that structure, I'm going to find that the commissioner, I'm not Batman, the gray commissure, all right, is going to be what helps connect the left and the right sides. I'm also going to see that from T2, where would that be? This is my cervical region, my thoracic region, lumbar, T, thoracic. So roughly T2 through L1. I'm going to see a lateral horn. This has got telefocus on now. Ah, it's okay. So basically, T2 to L1, I've got a lateral horn. Where is that on my spinal cord? Lateral is to which side? Outside. So I've already said that if I'm looking at a segment of my spinal cord, I've got my posterior horns, and now I've got some lateral horns. That's the reason why my sympathetic nervous system. Whoa. What? All right, so at this point, what we know. A vertebra, right? Okay, my spinal cord that's going through it. This would be the little end poking out from the back. Okay, is everybody with me on that? Okay, spinal cord. All right, now this stuff that we have talked about, where I've got this gray matter and then I've got my spinal nerve coming in. My spinal nerve coming in is carrying the information from my peripheral nervous system. Everything that is outside of the vertebra. Now, whoa, wait a minute. Sympathetic nervous system. What do y'all know about that? Fight or flight. Because I have sympathetic and I have parasympathetic. Sympathetic to me is not sympathetic at all, but that's just me. Okay? What parts of the body does that affect? My organ. So these lateral horns are for innervation that's going to occur with my organ. Now at this point, all the stuff that we have talked about at this point, how can any of this be clinically significant? At this point, you've learned that you've got the peripheral nervous system that is innervating for the most part to skeletal muscle, to sensor in the body, right?
I mean, kind of a more specific example would be if a patient was having issues seeing, you could use their pupillary reflex to see if it was actually being affected by the nerve signal to the brain, you know, whether it's being a bit of apparent pupillary safety factors, something along those lines. And then that would be a healthy narrow down using the nervous system as why they couldn't see.
Okay, now that would be involving the cranial nerves that are going to be located there, most definitely. Okay, and that's dealing with a very specific sensory input. All right, just like it would be for like the hearing or the the smell, that sort of thing. Let's bring it down just a little bit to this area from roughly C1 down. How can what you've learned at this point for the spinal nerves and now learning that I have the lateral horn that will affect organs, okay? How could any of this information at this point be clinically significant?
Would it have to do with the class values and like in other words that would be released if something happened?
What do you mean by something happening?
So like if you have a heart attack, then you can measure the percentage, but I don't know.
Now, in the case of a heart attack, because the cells break down, they release their components, and that's what they do test, and they're testing for the levels of that protein. Okay, let's think along the lines of injury, car accident. And let's say that we're going to have some decreased muscle function in the lower limbs and maybe some bowel issues, so to speak. Because there's nerves. They're going to have nerves in it. You see how I'm trying to get you to think about the topic? Because if somebody, say, for example, was in a car accident, for example, and let's say they injured their lumbar spine, not to the point they're paralyzed, I mean, you know, that's pretty much a given. But let's say they have continued leg pain, lower abdominal pain. Maybe they have some issues going to the bathroom. It's because that's the segments that are feeding that area of the body. And therefore damage to those areas would have an effect on what it leads into. That make sense? Okay, but definitely clinically significant about this. So, in the gray matter, I've now learned that I can have sensory information, I can have motor information, I can have organ information. Now, in the white matter, this is, look at what it has. The gray matter has what? Part of the cell. The cell body. The white matter is going to have areas of what? My axon. What? Does that make sense? Okay. So now, if in that gray matter, if I had my nerve cell body, the axon, now here, okay, and remember, axons are going to have to do this.